Hello students, how are you? Okay, let's begin a class in YouTube Live. By the way, I have given some documents yesterday on Moodle, na? Have you checked it? Sorting. So directly moving to the topic, what exactly sorting is and why we need this sorting thing. Actually, all of you know we do a sorting to keep all the numbers in some order. It may be ascending or in descending, right? So when I want to keep all of your roll number, it should be a sorted order so that we can search any roll number very easily. That is the actually main purpose of sorting. Okay. So to begin with, uh, I just recap yesterday topic on bubble sort. Okay, by the name of bubble sort, you already know. Just wait a minute. I think the board is clearly visible to you. It's a teeny board, and there are some. Okay, let's take some example directly. Okay, so I'm taking an example of few numbers. Let's take some numbers like this. Okay. Just assume we have an array, and in this array I have some numbers like 4, 3, 2, 10, 12, 1, 5, and 6. Okay, as you can see the numbers, I have a total 8 numbers, but you can see the numbers are not currently sorted. And what I want to do, I want to make this number in a sorted order. Okay, so for this, what the bubble sort algorithm is saying that just like a bubble moves upward from the below to the uppermost portion, just like that, we begin in this way. Okay, we have an array like this. Okay, I'm just moving this side. So now we have the numbers like this. We have 4, 3, 2, 10, 12, 1, 5, 6. Okay. So happens inside water. If you think about a bubble, the bigger bubble goes up and vice versa, right? So if we start from the first number, if we start from this number, what will happen? There is a comparison between these two, 4 and 3, and what will be the result? As you can see, the number 3 is less than 4. Okay, by the way, we are doing this in ascending order. Okay, so 3 is smaller compared to 4. So the series becomes, actually the number becomes 3, 4, 2, 10, 12, 1, 5, 6. Okay. So now what happens? The bubble doing thing will happen to the next part. In the first pass, we have taken this one. In the next run, we have to choose these two, right? So what I will do, just I'm writing this again, and here what we have 3, 4, and 2. So we have 4 and 2, right? Now 2 is less. So it becomes 10, 12, 1, 5, 6, as it is. The other part is actually taken as it is, right? Now moving to the next level, next step. So what happens over here? So we have done that exchange of array position from the first place here between the first two and then to moving to the second two, and then what we have to do now? We have to do this again for these two, right? Now here what we have 3 to 4, whatever. We have to compare 4 to 10. By the 4 and 10, in this case 4 is already less compared to 10. So the resultant will be again 3, 2, 4, 10, 12, 1, 5, 6. Okay. Why? Because if we compare 10 and 4, 4 is already less. That's why nothing happens to this. Is it clear? Okay. There is a problem, I think, technical problem. The board is not properly visible to you, I think. Okay, I think it's right now, na? We have done it for 4 and 10. So what we have to do next? Yes, you already know this. We have to do this for I'm sorry. I have to do this for in which number we already have done? In 4 and 10, right? So I have to do it for okay, already sorted numbers there. 3, 2, 4, where I already swap between two numbers, right? And then I have, okay, here I have to do this right now. Okay, 3, 2, 4, 10, 12. Again, if you compare, okay. So in this step, what we get is exactly the same as it is in previous step. So moving to the next step. So 10 for 10, 12 we already have done. For 10, 12, as we for this one between 12 and 1. See, every time the place is moving one place to the next place, right? So here what will happen? The list become 3, 2, 4, 10, 1, 12, 5, 6. Okay. 12, 1. So this is what we have after this particular step. Okay. So now we have to move. Okay, we have done the exchange, the swap between 12, 1. So it becomes 1, 2. So what will be the resultant list? It will be 3, 2, 4, 10, 1, 5, 12, 6. Okay, it's very simple. So so you can see the what we left is the last two digit. So in this pass, actually we have to sort to the final one as 3, 2, 4, 10, 1, 5, 6, 12. Okay, so here we finish in fast. By the way, if you see the program code, okay, I will show you the program code later. Actually, we already have done. I have given you the program for the bubble sort, right? By the way, I will write the program over here, but see, this is the result after the fast pass. Okay. Similarly, is the list sorted? No, the list not yet. So we have to sort it. We have to follow the same procedure again to sort it completely, right? In this way, we do the bubble sort. Okay. So now we are moving to the program code. Okay. So here is the code for the program. Okay, give me a minute. Okay, here I have the function for bubble. Okay, I'm just writing the function for bubble sort. Here it is. Okay, here I have a problem in my marker. No problem. Void bubble. I have to do bubble sort in an array integer arr and int. Okay, I'm just writing it first, then I will describe it. I have two variables, integer ij, and then a for loop I equal to I less than n minus 1, then I plus plus. Inside this loop, I have another for loop for j equal to 0, j less than n minus I. Okay. If is the board visible to you, na? Okay. So then if array, which I have taken over here, array for j greater than arr j plus 1. Why? J plus 1, why? Because we have taken the next one, the next value, that is j. When we comparing j to j plus 1, na, that's why the first one is placed in j and then the next one is j plus 1. Then what we have to do? In that case only we have to do the swapping, right? So here I can use a swap function, or even inside this we can write the program directly. We can directly swap the value. Actually, in we have done a program. I have written one program. And I will give you the program in Moodle. There, I use directly the functionality over. I haven't used this swap function over here. Okay. But for better understanding, here I am showing the writing the swap function. Okay. So ask, okay, is the board visible? I think it's visible. By the way, you can see here I have done the swapping for the numbers as I described in my first pass of the example, right? Now, why using two for loop? The first for loop is maintaining the pass and the second for loop is maintaining the swapping thing. Okay, this is all about the bubble sort, right? Now, okay, the given in Moodle, you have to check it. Now with the same number, insertion sort. Now what happens in insertion sort? Okay, we have these numbers. Okay, from the name, you know, insertion. We have to insert something somewhere inside our array, right? So what happened in an insertion sort is we start from the first element in the array, and then what we do, we just check the number with the first one. If it is smaller or larger, we do the swap thing, right? And in this way, we moving forward to do the insertion sort. Let's take the example for this. Okay, it will be very easy after explaining this example. I'm taking the same variable, same value actually, same element. Okay, in the beginning, what is the array? It is 4, 3, 2, 10, 12, 1, 5, 6. This is our array. Then, what will be the fastest in insertion sort? I told you in insertion sort what happens, it starts at the beginning. It is like this. Actually, the first two numbers are compared first. And then if the second number comparing to the first number, if it is less, as I am doing the ascending order, I am going to do the ascending order. What will happen? It moves to this place. So it will be like, and the array, the least become 3, 4, 2, then 10, 12, 1, 5, 6. Okay. So now what I already have done this thing to this 2 here. Now what I have to do? I have to do the same thing for this. Okay. So what will happen in this step? I have the value 2, 3, 4. See, in the first pass, I just compare in this 2 number. In the next pass, I am comparing this 3 number. Here 2 is less, so it is coming to the first place. Then 10, 12, 1, 5, and 6. Okay. So what will be the next step? We have to do the same thing for this up to this. Okay. So what will be the next level? Now, if you can see, if we consider one more number from the list, we are considering 10 over here. 10 is already in the sequence. So what will happen? The list looks like 2, 3, 4, 10, 12, 1, 5, 6. Why? Because already 4 is less to 10. That's why nothing happens in between them. Similarly, okay, now entire array becomes up to this point. Okay, in the previous level we have taken up to 10. So yeah, so up to 12 we have to take. Okay, so again 12 is less. I'm sorry, 10 is less compared to 12. So what happens? I have the list. The next list will be same as the previous one. Okay. By the way, it is not possible to answering in a live chat because I'm writing in the board now. So it is not possible to write your answer right now. I will reply to all your queries in this chat session or in WhatsApp. Okay. Okay. So 2, 3, 4, 10, 12, 1, 5, 6. So what happens here in this step? 2, 3, 4, 10. Okay. Now what will happen? The same thing will happen up to this. Now, if you consider this array, right, from 2, the least become. Now, when I'm taking this next value after 12, I have to take the next value after 12. So, after taking this value 1, I have to compare this to the previously stored sorted array, right? So, I have to compare to the entire array element, and as it is less, it becomes the first element. 1, 2, 3, 4, 10, 12, 5, 6. Okay. So okay, I have done in this step. I have done up to this, right? So what happens now? What I have to do? I have to take up to this, right? So now you can see I have the next value after 12. I have taken 1 is already sorted. Now I have the next value as 5. And after comparison 5, after compare 5 with all other values stored in my array, it should move to the place like this. 1, 2, 3, 4, then 5, 10, 12, then 6. Okay? And the next step will be the entire array. Then it will be like this: 1, 2, 3, 4, 5, then 6, then 10, and finally 12. So it becomes the sorted array. Now what happens if you see this diagram? If you compare to the bubble sort, we were in bubble sort, we are comparing one value to the entire array. But here I'm comparing a single value with the previous array, previously sorted array. That is what we have to do in our program. Okay, let's write the program. Okay, I will write only the function. Okay, yeah. So here is the function for insertion sort. I have an array, integer arr, and then integer n. Okay. So integer I key. Okay. Here we need a new function, actually new variable called key. Key is what? That number I am going to compare with all other number. That is the key. Okay, that's why I have taken another variable called key. And then j, just like the previous one. Then, and in the beginning, the key will be the first value. Okay, so inside the for loop, what I have, I equals to 1, I less than n, I plus plus, and then inside this for loop, what I have, key equal to, okay, the first element. Key equal to, I have assigned key as the first element, and then j equal to I minus 1. Okay, inside this for loop, I have to use a one while loop. While loop, why? Because actually I have to compare that particular value to the previous one and the next one. Okay, that's why while j greater equals to 0 and arr j greater than p. Okay, I'm writing this just above. E. Okay, I have already written the while. Then here arr j plus 1 equal to arr j. This is exactly what we have done in our example, and then j becomes j minus 1. Okay, this is okay. I'm going to write. Okay, j equals to j minus 1. Then okay, I'm just erasing this line. It is not possible to write the entire thing in the board. Okay, I will give you the entire program in Moodle. Right now, j equals to j minus 1, and then arr j plus 1 equal to keep. Okay, this will be the function. Understand what insertion sort is. Okay. Okay, let's take a break. Let's have a look on your message. Okay, there is a reflection in the board, na? Okay, I'm trying to remove the reflection from the board. I think the reflection is gone, na? Okay, you are what you are seeing. It's in mirror, na? Okay, no problem. I will give the entire program code in our Moodle on selection. Okay, what we will do now is selection sort. Okay, to select, you have to select the minimum number, and then you have to place that number in the beginning of the list. That is what we do in selection sort. That is the main thing actually. So two things we have to do in selection sort. What? First, what are the numbers? 4, 3, 2, 10, 12. So the numbers are 4, 3, 2, 10, 12, 1, 5, and 6. From this number, what I have to do, I have to find the minimum element, and then I have to replace it with the first one. That is what we have to do. Which one is the lowest? This one is the minimum. 1. 1 value is the minimum value. Okay. So the list becomes after first checking, the list becomes 1, 4, 3. List number in the entire list. So it is already sorted. The first number is already sorted. So the same thing I have to do in the raised part inside this. Now inside this, what I have, 2 is the lowest number, right? So in pass 2, what we will have, it becomes the list becomes 1, 2, 4, 3, 10, 12, 5, and 6. Okay. So now 1 and 2 is 2 are already sorted. Now the rest, actually these are the unsorted part, and this is the sorted thing. Okay. In next level, I have 1, 2 sorted, and 4, 3, 10, 12, 5, and 6 are unsorted. So here I have the unsorted list. So what is happening? The sorted list is increasing and the unsorted list is decreasing. If we start from n, the sorted part is increasing to n and the unsorted part is decreasing to 0. Okay. So 1, 2 is sorted. What will be the next level? 1, 2. Then inside this unsorted part, I have 3 as the minimum number. So it becomes 1, 2, 3, and then 4, 10, 12, 5, and 6. This is the next step. So now I have the sorted list as 1, 2, 3, and unsorted list as 4, 10, 12, 5, and 6. Okay. So, okay, mirror view you are watching, na? Okay, that is a problem. The board is not visible. Okay, no problem. The level letter, and I will give the program after I finish this. Okay, and I'm just describing this. You just listen to me. Use a headphone. If the sound is very less, use a headphone, and then okay. Now I have a. You can see the sorted list as 1, 2, 3, and then unsorted list as 4, 10, 12, 5, and 6. Right? So in this unsorted list, I have to find the minimum number. Which one is the minimum? It is 4. So the list, the new sorted list becomes 1, 2, 3, 4. Then this one is the sorted part, and then 10, 12, 5, and 6. This becomes the unsorted part. Right? Similarly, by moving, finally we 10, 12. So this is exactly happens inside the selection sort. So why the name is selection sort? We have to select the lowest element and then we have to move to the first place. In case of we are doing this in ascending order. Okay, let's have a look in the program code. Okay. It is very easy actually. Just like the previous two sorting algorithm, here I am writing void okay, integer I, j, min. As I told you, here I am taking a new variable called min, by where I have to keep the minimum value. Okay. So for I equals to 0. We start from the beginning. I less than n minus 1. I plus plus the increment. Actually, we have to search for the minimum number inside this loop. Now, what I'm doing, I'm assuming the minimum value as I. If, okay, I have to choose the minimum one, na? If ARRJ less than ARR min. Okay, then min becomes J. Min equal to J. And then I have to apply the same swap function. Swap. I have to swap the minimum value to the first value. So the swap between done. Okay, from this program code you can see this is the simplest one. Actually, when we writing the C code, it is the simpler one. We only have to check for the minimum one. Then we have to place the minimum value to the first place if we maintain an ascending order. Okay, now actually when we talk about this algorithm, actually we have all the algorithm available all the time. Now, which algorithm should be used for which purpose? Actually, if I give you some example like this, if I want to sort a deck of playing card, in that case, I have to choose insertion sort. Because what we do in a deck of playing card, I just take, by seeing the card, I just take, are some okay, let's there is a provision. Actually, I have written 3 functions. Now, in these 3 functions, I have written 3 different. Actually, for the selection, for the bubble sort, I have used 2 for loop. For the selection sort, I used 2 for loop, and then if. Now, for this, to do the entire iteration, you need some time. Actually, that is called the complexity of that algorithm. Okay. Now, every algorithm has some time complexity, right? Now, how much time it needs to run in best case? When best case is what? When I have a sorted array, that is the best case. And worst case is what? The entire array element are not sorted. That is called worst case. There is in between case between the best case and worst case, that is called average case. Okay. So we have to calculate the complexity, the time based on the memory space usage. Okay. So here, if we consider the time complexity of bubble sort, what we have done, insertion sort and selection sort, the best case complexity in bubble sort, we have order of n. And same thing for insertion sort. And but if we chosen the selection sort, the time complexity is in order of n square. Actually, the complexity is represented by order of something. So n is the number of element present if we consider the array, or number of iteration happening inside the program. Okay, so I will give a lecture on complexity, especially time complexity, in my next lecture. Okay, so thank you for now. By the way, I think you have some problem watching the blackboard, right? Okay, you are getting some mirror view, and it is not possible for me to. Okay, I have. Mm, okay, I am just ending the stream right now. Okay, thank you all.